coefficient of friction. Mathematically, coefficient of friction is directly proportional to the normal reaction of a body. So this body resting on a horizontal floor, a rough horizontal floor, the coefficient of friction denoted by mu, F, is always proportional. The frictional force is directly proportional to the normal reaction R. The constant of proportionality, mu, is equal to F over R. Okay. When the body is resting on a rough horizontal floor, and this body is being pulled by a force, say P, then the frictional force will act opposite in the direction of the movement of the body. We have a force that acts vertically upwards and is always perpendicular to the plane, called the normal reaction, which is always perpendicular to the plane. The normal reaction R, and then the weight of the body is F, that acts at the center, called the center of gravity, which will move vertically downwards or act vertically downwards, W equal to mg. Okay. From the diagram, when we look at all forces moving in the x direction, summation forces in the x direction, you can see that summation F of x, all the forces in the x direction, should be equal to 0 when the body is in equilibrium. The forces addition in the x direction should be equal to 0. So the forces in the x direction, we have P, which is moving in the positive x direction, P, and then F moving in the negative x direction, so minus F should be equal to 0. So always a body with this become equal to P is equal to F. The force in that direction is equal to the frictional force. Okay. Summation forces in the y direction should be equal to 0. Forces in the y direction have R positive minus mg equal to 0. So R equal to mg. Okay. But we know that F is equal to coefficient of friction times the normal reaction R. So from here you can do substitution, saying that our coefficient of friction, so R equal to F over mu this way. So you can do substitution here. In case you are given your coefficient of friction, they ask you to find the force, the frictional force, you can do substitution to get your frictional force. Okay. Now let's look at the body resting on an inclined plane. The body is resting on an inclined plane, and this body, I try to increase the angle of inclination, say theta. This is the angle of inclination, theta. I try to increase the angle of inclination so that the body resting on the plane starts to slide down. Then the frictional force, when the angle here is, the angle of inclination is increased for the body to start sliding down, then the frictional force will act in the opposite direction, F, this way. The weight of the body, that is center of gravity, will act vertically downwards. That's mg, weight mg. Then the normal reaction should always be perpendicular to the plane, always form an angle of 90 to the plane, this way. So there's the normal reaction R. Okay. Resolving all the forces on this plane, Then choosing the Cartesian coordinates, this form, y, x, y, negative x, meaning that it will be only mg that will follow this Cartesian coordinates, w following the negative y under this coordinate. R is not in this coordinate, that means we need to resolve r. Then f2, we need to resolve f. But when you choose your Cartesian coordinates in this form, you can see that your y follows the normal reaction, the s follows f. The only thing here to resolve will be mg. So I think this Cartesian coordinates is the right choice. So resolving mg, we need to resolve mg to both horizontal and then the vertical component. If the angle here is theta, then from theory we know alternative angle forming the z shape, here. So that means this side too is theta. Okay. This angle is total 90. So here will be 90 minus theta. Then when I trace this one downwards, you can see that this side too will be 90 minus theta and this side theta. Adding all here should give you 180. So theta plus 90 minus theta plus theta plus 90 minus theta. And so this one will nullify this. This will go 90 plus 90 giving us 180. Meaning the angle here is theta. Okay. Resolving the angle in the Cartesian coordinates form, meaning this side become the adjacent, this side become the hypotenuse, this the opposite. Okay. So finding the side here, you can see that let's know this side by say y and this side by x. To find y adjacent, so cos the angle theta cos y over the hypotenuse, which is mg. We have y equal to mg cos theta. S becomes the opposite, so sin theta equal to the opposite x over the hypotenuse mg. So s equal to mg sin theta. Okay. So the direction of the force mg or the weight moves vertically downwards. So moving from here to here, it means I can move this way. The direction is very important. This way, then to this side, this way. Okay. The direction of x is the same as this side. So if this x is mg sin theta, that means here is mg sin theta. And then the y, mg cos theta. Okay. Now, summation, all forces in the x direction should be equal to 0. So we're going to sum all the forces in the x direction. Forces in the x direction, using our Cartesian coordinates in this form. Based on x direction, the forces moving in the x direction, we have F here moving the positive x direction, so F. Then we also have another one here moving in the negative x direction, minus mg sin theta. Then we also have, okay, that's the only forces moving in the x direction, F and then mg sin theta should be equal to 0. Okay, so from here you can see that F becomes equal to mg sin theta. Call this one equation dada. Okay, summation forces in the y direction should be equal to 0. Forces moving and at this coordinates, Cartesian coordinate, in the y direction, you have r in the positive y direction, and then you have this moving in the negative y direction, so minus mg cos theta equal to 0. So making r the subject, have r equal to mg cos theta. For this one, equation Okay. So now let's divide equation data by equation from theory. We know that coefficient of friction is F over R. So dividing equation 1 by equation number 2, equation data by equation we have F equal to mg sine theta over R this over mg cos theta. Okay. Note that F over R is what we call the coefficient of friction, mu. This one will nullify that, and then sine theta over cos theta is equal to tan theta. Okay, so there is another relation between coefficient of friction and then the angle of what? Inclination. Okay. So when the body is resting on an inclined plane, provided the body is resting, we try to increase the angle of inclination such that the body starts to slide down. Then the frictional force will move in the opposite direction. Then you can resolve the forces acting on the body to both horizontal and vertical components, provided you choose the correct Cartesian coordinates. Okay. Thank you.